Welcome to Talk Universe. Tonight's show is for Wednesday, January 25th, 2017. We've had some interesting shows so far this year, and I've got a small addition to the show. I have an automated co-host, my computer, and tonight's show is going to be an open lines show where we take questions about space travel. So it's a targeted open lines show, and we've got some interesting questions already lined up. And so let's see if the co-host is ready. Computer.
Hello.
Are you ready for tonight's show?
Yes, I am.
And what is tonight's show about?
The topic of Talk Universe tonight is space travel. We will take questions and comments on the air.
I think at some point I'm going to have to come up with a name for you. Would you like a name?
I have no opinion about the matter.
Well, I probably should give you a name.
I suppose you could if you wanted to.
Okay, so are you ready for the show?
Yes, I am ready for the show.
Okay, this is going to be a great show tonight. We are, again, talking about space travel. We'll look at the technologies. We've got a number of questions from people and a couple of interesting opinions. We hope that you saw the posts on social media a little earlier, so you had an opportunity to send us your questions and emails. We do have a few that have come in already, some by text as well. And we'll be taking those live on the air tonight. I also want to welcome all of our new listeners. We have a number of them all over the world, and we're getting a reasonable number of hits on the site. I like to see the show growing. It means people are enjoying it, and we're making an impact. Now, through it all, we're going to keep the same format. We still have our Singularity Watch and our book recommendation, and we'll still do interviews, and nothing really is going to change the format. But if you have any questions or comments or suggestions about changes or improvements to the format, we'll also listen to those as well. You can see us on Facebook, and you can also send your emails to admin, A-D-M-I-N, at talkuniverse.org. Okay, and computer, could you repeat that email address? Where do listeners send questions or comments?
Send your questions or comments to admin, A-D-M-I-N, at talkuniverse.org.
Very good. Okay, so let's get started. Now, we have a number of these questions tonight, and so, computer, let's get going with the questions, please.
We have many questions tonight from listeners online and from emails. Roger from Twin Falls asks, how fast do satellites orbit the Earth?
Okay, Roger, that's a good question. How fast do satellites orbit the Earth? And the answer is actually not a single number. It depends on how far you are from the Earth. Closer satellites move at about 5 miles per second. It takes you about 90 minutes to go around the Earth. And the reason for that's real simple. If you were to go 5 miles straight ahead on the surface of the Earth in a straight line, the curve of the Earth is such that the ground would drop away about 16 feet. And the acceleration due to gravity is a little over 32 feet per second. So every 5 miles you've traveled forward in a second, the ground has dropped away by 16 feet, and you would have fallen 16 feet. So if you do that, you're in a circular orbit, because if you're moving forward, the ground's falling away from you at the same rate you're falling to the ground, you maintain your distance. So orbit just means you're falling at the same rate, and you're moving forward enough that you miss the Earth. So for low Earth orbit, you're moving about 5 miles per second. The higher you go, the slower your orbital speed is. And to give you an example of that, the moon is 240,000 miles over our heads, and it takes over 28 days to go around the Earth. So that should give you a little bit of an illustration. So no faster than about 5 miles per second, unless they're on a long looping orbit like a really steep ellipse, and then sometimes they can really fly. But that would be your answer, Roger. Okay, computer, what's the next question?
FJ23 asks, how many satellites are in space?
That's an excellent question, actually. Okay, FJ23. Over time, there have been roughly 10,000 satellites launched. And that's from the very beginning of the space age in the 1950s all the way to now. However, satellites have a limited lifespan, so many of them re-enter the atmosphere or burn up or are commanded to do so. So most of the satellites that have been launched have actually come back to Earth. Right now, you get different estimates depending on who you talk to. One estimate was about 2,300 satellites are presently in orbit. Another one from the United Nations said about 4,256 satellites are in orbit, but about a third of those are operational. So that would mean about 1,400 working satellites. That's a number they seem to agree on. If you look at the number of objects in space, because there's also a lot of debris, and some of it can be an unintentional satellite. You launch a rocket stage, and a piece of that stage remains in space while the rest of it falls to Earth. If you count every object greater than 10 centimeters, or about 4 inches across, there are about 21,000 of those. And if you keep track of all the debris, the nuts and bolts, the gloves, tools, things that have been lost in space from exploded boosters, damaged or collision hardware, all that sort of stuff, pieces that are from 1 to 10 centimeters across number about 500,000. So I think we can agree that there are about 1,400 or so working satellites in orbit right now. About 10,000 of them have been launched, and there's between 2,300 and 4,200 or so. And that would be probably your best estimate. About between 2,300 and 4,200 satellites orbiting the Earth right now. Okay, computer, what's the next question?
Penny from Idaho wants to know how astronauts going to the moon passed through the Van Allen radiation belts without dying.
Now, that's a question I've heard before, and a lot of people don't believe we actually went to the moon. And believe me, we did. We did go to the moon, and we did have the capability, and we presently do have the capability to do it if we really wanted to. The exposure to the radiation of the Van Allen belts was very brief, and there was another trick that was used. Because we were at a real weight disadvantage for what we could fly, they had to use a couple of tricks to help minimize exposure to radiation. One of them was this. Old Russian spacecraft often had steel shells as the hull. And the steel has an unfortunate side effect, and it was that when cosmic rays and energetic radiation strikes the steel, it emits secondary particles, secondary radiation. This is because when a cosmic ray, which is basically a stripped atom, smashes into a metal atom like steel or iron at high speed, it fractures the iron atom into hard radiation. It emits a lot of radiation. So being in a steel shell could give you an extremely high radiation dose very quickly. If you're in a lightweight aluminum or magnesium or titanium or even some sort of composite spacecraft shell, much of the radiation will pass right through it and you very rapidly and do much, much less damage. So it actually was a matter of simply letting the radiation pass right through their bodies and minimizing the amount of exposure time because they were moving pretty quickly. So they were able to cut the exposure down to a few hours out and to minimize it by using no steel in their immediate vicinity or heavier metals, because that would actually increase the radiation hazard. So there is a cumulative dose, but it's one of the reasons we didn't have a lot of women early on in the space program, because ovaries contain a lot of eggs, and the eggs can be damaged by radiation, and they will retain that damage for a significant period of time, and then babies born later will carry genetic damage. Men, on the other hand, they have a much smaller target area for radiation damage, and as a general rule, sperm cells are replaced every few days, and so you're much less subject to damage from radiation if you're a male than if you're a female. And that explains, it wasn't a sexist thing, it was simply that from a biological and pragmatic standpoint, it made sense to send men into space because they're far less liable to receive long-term radiation damage genetically in their genetic material. Computer, what's the next question?
Jim from King of Prussia asks, how many stars are there in the universe?
Jim, that's a great question. If you look at galaxies, they're all different sizes. And our Milky Way galaxy is a fairly large galaxy. It has an estimated, right now the estimate is something like 300 billion stars in it. We know now that there are roughly 2 trillion galaxies, and many of them are smaller than our own. If you took an estimate of 100 billion stars for a galaxy and 2 trillion galaxies, then you end up with something like 200 billion trillion stars, 2 times 10 followed to 23 zeros, 10 to the 23rd power. So imagine a 2 followed by 23 zeros, and that would be approximately how many stars there are in the universe. And, those numbers are subject to change as we discover more things like a bunch of small galaxies or a bunch of large galaxies or what the averages are. But that would be just a good running estimate. About 200 billion trillion stars. And I hope that answers the question for you. And an example I like to give when we talk about our galaxy is imagine a basketball court filled with coarse builder's sand about a meter or so deep. And you pull one of those grains out and you paint it blue and you throw it back in and mix it up in there. That one blue grain would represent our sun and our planets, our whole solar system. And the rest of the sand would represent the stars in our galaxy. And that gives you an idea. Finding one grain painted blue out of an entire basketball court about a meter or so deep in sand, that represents our galaxy, and the blue dot represents our solar system. So that should give you kind of a concept of the scale of the thing we're talking about. And that's just our own galaxy, one galaxy out of 2 trillion, which is 2,000 billion galaxies. Okay, computer, what is our next question?
Holly from Winter Park says that there should be a way that colleges and schools can launch satellites for projects.
Actually, Holly from Winter Park, and if this is the Winter Park in Florida, I believe it is, which I'm familiar with, there are methods of colleges and schools and students launching their own satellites. There's even a standard called the CubeSat standard, which has been around for a number of years, decades. Basically, it is the dimensions of a standard defined miniature satellite, which is 10 centimeters in a cube and weighing about 1 kilogram. The idea is to keep them durable, lightweight, have a standard instrument and control bus. And they've been carried on the space shuttle, and they've been carried in other systems as well. So there are a number of companies that arrange for a satellite, once it's been vetted, everything in it is shown to be safe, to be carried into orbit. Now, a lot of times when they launch, there is no guarantee that your satellite will maintain orbit, but it will have been launched into space, and it will go around the Earth a few times, most likely. And some of them have been up there for a number of years. So there are ways of doing it. If you go online and you start looking at students or colleges and CubeSat, C-U-B-E-S-A-T, CubeSat standards, you'll find that there is a way to do it. And if you are trying to get your own satellite built and launched into space, you actually can do it for very reasonable or sometimes even nothing. So it's worth going online and looking for CubeSat standards and seeing who will launch for you. So this is something that we actually have made some advancements in. Students can get their stuff launched into space these days. We've actually got some pretty good questions here tonight, and it seems everybody's staying on topic. Computer, what is our next question?
Lance from Mayhill says, isn't all this money we spend on space better used here on Earth? There are a lot of poor people who could put it to good use.
Lance from Mayhill. This is a hot button topic when you talk to people who are space advocates, and there are some very good reasons for it. And I'm going to have to continue this after the break, which is coming up. But I'll say this. A lot of times we've been told we ought to fix all of our problems here at home before we go off and do anything else. Well, unfortunately, life isn't that simple. For one thing, if we were told, well, your city isn't allowed to have a monorail because the other 3 cities out here have a lot of poor people, we'd never get anything done if we followed that sort of thinking. You've always got to have advancements, and space and space exploration have contributed more to our way of life and our well-being and our profitability than anything else, our understanding of the universe. And like I said, I'm going to get onto a rant on this one. I'm going to pick this one up after the break and keep going with it. But think about it. What would our world be like if we had no electronics, no high-speed aircraft, no microwave ovens, no computing? It would be a very poor place indeed when you think about all the advantages we gain from those things. This is Talk Universe. I'm Sir Charles Schultz, and we'll be back after the break. Okay, we're back from our break. Computer, please repeat the last question.
Lance from Mayhill says, isn't all this money we spend on space better used here on Earth? There are a lot of poor people who could put it to good use.
Okay, so that's the question, and I have a lot of thoughts about that. As a particular futurist had once written, it's not like we're putting the money in a barrel and just shooting it off the planet somewhere. When we build a spacecraft or we start a space project, we can see a lot of immediate benefits. Number one, a lot of educated people are hired to do the design and build the hardware, and they have to buy composites and metals and electronics and specialty material, which means that people are employed by the places that make those things, the factories that produce them. And so there's a lot of jobs there. And those people have to buy materials to make those microchips and metal parts. And so there are factories that have to go out and do the mining and the refining and production of the materials. And basically what happens when you buy a really complex high-tech device like a spacecraft is you put thousands or tens of thousands of people to work. So the first immediate benefit that we see is that a lot of people are working. They're not just sitting on their hands. They're doing something, and they're producing something, and they're making the infrastructure of our economy viable. They're making it available for all the other things we need, like the electronics in your car or your cell phone. And, again, we're not just blowing the money in a barrel out into space and saying, okay, that's a good job. We hire an awful lot of people, and all of them are working. But the other benefits that a lot of people aren't aware of, it used to be said that for every dollar we invested in the military, we'd make a $5 profit, and that was about the right number for it. But every dollar we invested in aerospace and space travel would bring from $10 to $15 back in gross national product. So for every dollar we put in, we're getting $10 to $15 back in our economy. Now that makes space travel the tail that wags the dog. It really is something that makes an immense contribution to our economy. If you look at the amount of money we spend on other things, if you look at the federal budget for the last couple of years, we're spending about 8%, according to their numbers, of the money that we bring in. And we're talking like $4 trillion, $4.1 trillion was for 2016, I believe. Of that $4.1 trillion, roughly 8% of that was spent on interest on loans that the government had taken out, and less than 0.5% was spent on everything that NASA did, about $18 billion. When we look at the amount spent on repaying money to Social Security and housing services and that sort of thing, we see roughly 30 to 40% of our budget tied up in social services and welfare and putting money back into Social Security that the government took out and is having to put back in. And keep in mind that Social Security does not cost us anything because you and I are made to put our money into it when we work. It isn't free, and the government doesn't pay for it. It doesn't come out of our taxes. We put that money in there. So when we get right down to it, space travel and space exploration is really one of the most profitable and helpful things we can do because it puts a lot of people to work. We recently hear that there's the highest percentage of employment in our economy lately than there's been. So that's a lie. It's a downright lie. There's something like 95 million people in the 350 or so million of the U.S. that simply can't find work, and they've completely dropped out of the system. And right now, literally 47% of all households in the United States are on some form of welfare or social assistance. Think about that. Half of the country is receiving money in taxes that other people are having to pay to keep them going. That's intolerable. We need people working. And, they say the employment is highest that it's been. It's cooked books. You're using numbers that don't take into account all the people who simply can't find work and have given up on the prospects. If we really had a healthy economy, we'd have the highest employment, and we really have basically the lowest percentage of people employed in our population since about World War II. So don't fall for the cooked numbers. Space travel is an easy answer. High-tech industries are a very easy answer. We need educated people and we need more jobs. Space travel is certainly at the forefront of it, and I would support it 100%. It doesn't cost us much and it pays off hugely, not just in economics, but also in our way of life. Computer, what is our next message?
Spencer12 texts us, I found a cool satellite tracking app online called JTrack 3D. It shows where satellites are in real time. Could you share this site on your show?
Yes, Spencer12, that's excellent. I am familiar with JTrack 3D. I've used it for a number of years. And basically what it is a program that shows the locations of many of the satellites orbiting the Earth in real time. So you literally can go out in the evening and spot a satellite, then you can run indoors and pull up JTrack, and you can see the name of it, who owns it, and where it's going. You can learn a lot about it. So it's an interesting and fascinating program. Go online and do a search for JTrack 3D, and you will find the main site and a number of mirror sites. NASA hosts the program, and other sites mirror it. And go online with it and pull it up some evening and watch what's coming to your area, then go outside and spot it. You can see many of them with the naked eye and very easily with binoculars. JTrack 3D. I recommend it highly. It's a lot of fun. Okay, computer, what is our next question?
Melanie from Austin writes, what are the chances of getting hit by a meteor?
Wow. Okay, it's extremely, extremely low. I only know of one case that it's ever happened, and it was in 1954. A woman by the name of Elizabeth Hodges was hit in her home. And what happened, she was sitting in her home, and a meteorite, to be technically correct, that weighed about 8 pounds, crashed through the roof, bounced off her radio. It hit her radio and bounced off, and hit her as a result. And so that's the only person I know of that was ever hit with a meteorite, meteorite. It seems to me I heard a story about somebody who had a near miss or something a few years back. But since there's an awful lot of people in the world, and the world is a pretty big place, and I only know of one, really know of one case that has happened, you know that in the last 100 years, it's 1 out of 7 billion in 100 years. It's got to be awfully low. I wouldn't place any bets on it, I'll put it like that. Okay, computer, what is the next question?
Armando from Brazil says, what is star jelly?
Oh, that's a weird one. Okay, many years ago, it was noticed that sometimes when meteors were seen to fall and people kept track of them and tried to find out where they'd gone, they would often find in the expected impact area a strange jelly-like organic material that they named star jelly. And it happened enough that they made an association between it. And nobody knew chemically what it was made of, and maybe it was something from the Earth, maybe it's something that fell from space, but it was something that they found associated with the fall of a meteor or meteorite. And it had the odd property of evaporating away rapidly and leaving little or no residue behind. Some scientists who have looked at this feel that it might be organic matter that was formed in space and was frozen or, in a state where it wouldn't simply evaporate away. And when the meteor falls to Earth, it might have some of this accompanying it. And a lot of people disagree, but the fact is we have actually found meteorites that have caused local disturbances such as bad smells and generation of chemicals and other things. So it isn't something that is technically rigorously proven, but it does appear that in some cases when we have meteors fall, that some sort of organic material sometimes appears along with them. So it's certainly worth someone being able to investigate it if they could get there in time. And with all the people these days that have smartphones and digital communications, it should be simple enough to get a good picture, a sample in a bottle or something if it's ever spotted again. So I'm looking forward to the point where we actually have enough cameras and people who know how to use them out there, just like we do with cell phones. Everybody can take a selfie certainly they could take a picture of one of these sites if it ever falls again. So that's what star jelly is, something that is thought to be accompanying the fall of a meteor or meteorite to the Earth. A rare and hard to pin down material, and it's debated whether it's actually what they think it is. Computer, what is the next question?
Kelly M1994 asks, can you see asteroids from Earth? How can I do it?
Okay, I like that. Anybody who's an amateur astronomer knows, yes, you can see asteroids from the Earth, but there are only specific ones that you can see easily. Typically, they are the largest asteroids, or a dwarf planet such as Ceres, the largest asteroid in the belt. And they do often end up in a position known as opposition, where they are farthest from the sun, opposite the sun from the Earth, and so they're well illuminated, and sometimes their orbits will bring them close enough so that we can see them with binoculars, and rarely with the naked eye. You have to have really good vision and be in a very dark sky site to see them. But yes, you can actually go out with a good pair of binoculars. You go online to some of the astronomy sites, and Sky and Telescope magazine and Astronomy magazine are two that you can go to, and they will list a star map or a sky map for the month, and they will often have a column that mentions which asteroids you'll be able to spot. So if you go outside, dark skies, good seeing conditions, and a good pair of binoculars, and you know where to look, you, yes, can actually see asteroids, some of them. And normally use a technique called star hopping. You will locate a bright star or a couple of stars you recognize, and then you will go from there and hop to a smaller, lesser known or dimmer star, and you go like from stepping stone to stepping stone. You follow star to star until you get into the region where you expect it to be, and then you can watch how it moves over the next few nights, and they usually move quickly enough. They're very easy to track if you know where to look. So yes, Kelly, it is possible to see asteroids on the Earth, and all you need is good binoculars and a little patience and a good sky map predicting where they will be. Okay, computer, how are you doing?
I don't understand your command.
Okie dokie. Are you ready?
Yes, I am.
Okay, very good. Let's continue. Computer, what is the next question?
Arthur from Pascagoula asks, what is the largest spacecraft or payload ever launched into space?
Now you'll get some debate about that, but I think that the largest spacecraft that's regularly launched, of course, was the space shuttle, and the max payload that it would carry would bring it in at about 115 tons. Often people will say Skylab, which was really a third stage of a Saturn V. Skylab was 77 tons, and it was pretty huge in its day. It was just about the biggest thing launched. But and that was in the mid-1970s, and I remember seeing them, the missions being launched. But overall, the largest, heaviest payload or spacecraft ever launched in one go is probably Apollo 17. It had the third stage full of fuel to do the lunar insertion, and it went up fully loaded with a command and service module and the lunar module, and overall it came in at about 143 tons. So the Saturn V was a real brute. I mean, it would put 150, 145 tons in orbit at a shot if you needed it to. And Apollo 17 was a proof of that at 143 tons. And I think that if you look at the numbers, that's probably the single largest object or payload ever launched. And hopefully we'll be able to do something like that again very soon. Now, at present, our strategy is to make multiple smaller launches, and it's very possible that we could launch a fuel tank, an instrumentation and equipment module, and a crew module, and join them all up in orbit to make one larger spacecraft. So it would be 3-4 smaller launches taking up components, and then all the components meeting up and being turned into one spacecraft once you're up there. And of course, we certainly have a lot of experience doing that, building the International Space Station. And we'll be back with Talk Universe after the break. I'm Sir Charles Schultz.
This is Talk Universe.
I really enjoy doing a good show, and when we have good questions and interaction with listeners, it's particularly rewarding to be able to get them some answers. And these are some good questions tonight. So let's get back to it. Computer, what's our next question?
Kevin from Ontario wants to know how long it would take to get to Venus.
Kevin from Ontario, getting to Venus. Well, now that depends. When we talk about getting to, for instance, Mars, we know that when it's a close approach, we can get there in between 7-8 months, somewhere around there. But we also know that we're firing our engines forward to go farther out in orbit. When we go to Venus, we fire our engines in the opposite direction to slow down and drop in closer to the sun. And it usually takes anywhere from about 7 to 12 months, depending on the type of flight we're doing. Now, Venus isn't really very far away. It's only, it's about 67 million miles from the sun. We're about 93 million miles from the sun. So you'd think you'd only have to go, less than 30 million miles to get there, like 26 million miles. But the fact is, you're traveling in a long looping path around the sun. And so Venus has already gone around the sun once by the time you get there, pretty much. But it's going to run between 7 and 12 months, depending on the type of flight path you have. And, we're using traditional rocketry today. Once we start getting into plasma engines and other types of technology, we can actually cut that down to a few weeks or a few days. So it's going to depend on whether it's a ballistic flight, which is, virtually every flight we make right now is a ballistic one, or something done with a continuous thrust like a plasma engine or something similar to that. But right now, count on the better part of a year. Computer, what is our next question?
Mapleleaf 22 says, I listen to your show all the time and I really like it. What's the best way to get something to Mars?
Okay. Right now, of course, we always use rockets to send things to various places. And those rockets have, and I mentioned plasma engine a little earlier, there is an ion drive that we use that can get things there a little faster sometimes, but it's an extremely low thrust. If we send a payload to Mars, right now, it has to go by rocketry. And again, that takes about between 7 and 10 months, depending on your flight path. If, however, we were to use a different technology, and those are being worked on, we would be able to cut that travel time down immensely. For instance, if we had just a fraction of a G of thrust, we could cut that down to a month. And if we had up to a full G of thrust, the same force you feel holding your feet to the floor on the Earth, we could cut that down to less than a week. And believe it or not, it wouldn't matter even if it were on the other side of the sun. We could still make that trip very, very quickly in just a few days' time. So for now, the best way is you use a rocket and you let it coast most of the way there. And in the near future, we'll probably be using plasma drives, which will get it there in a few weeks or days. Computer, do we have any more questions tonight?
Yes.
What is the next question?
Tyson Fan from New York asks how a factory in space would make any money.
Yes, that's an interesting concept. When you think about it, we are moving towards space factories and asteroid mining. So how would you make any money? Right now, the biggest moneymaker would be the fact that by manufacturing things in space, you're not paying the launch costs. It takes an awful lot of money to get something launched off the Earth. It's an extremely expensive prospect at this time. So anything that you can manufacture with local materials and goods immediately cuts the launch of your system, or the cost of your system, by a huge fraction. For instance, some numbers say it's $10,000 to get a kilogram into orbit. And that, is probably a pretty good number. With the things that SpaceX is doing, we can cut those costs down eventually because they have reusable launchers, which means that a large part of the cost building the actual launcher and the engines and everything is removed. You can get 3, 4, 5, 10 shots out of the same engine. Well, then that's great. And that has a direct scale factor on the cost of launch. But the big thing is, If you're planning some sort of an operation in space, you have to pay for all of that stuff up front, plus the launch costs. If you're able to get it manufactured in space, you can cut your launch costs way down because the cost of delivering it to space is effectively zero since it's already made there. Space factories are really going to come into their own when we have a lot of industry in space and a lot of people living there. And don't misunderstand, if we're manufacturing things in space, they are probably not things, for the most part, that you're going to bring back to the Earth and use on the ground, because that sort of defeats the purpose. There are certain materials and things that we would bring back to the ground, and precious metals obviously have a big market and are part of the monetary system. So you know that people are going to be bringing back platinum and gold and iridium and other expensive platinum group metals and expensive metals. But we also have some things we can't make on the ground that you would make in a microgravity or space environment. And one of those things would be, for instance, fluffy ceramic for bone replacement and fluffy metals, foamed metals made for making lightweight metal products that don't have a solid metal disc in the middle. We're reaching the point where 3D printing can do a lot of that stuff on the ground, but there are still some materials that are better made in space where there is microgravity. So the space factories are going to make their money or their income in trading materials that can only be delivered very, very cheaply to orbit, or things that can only be made in space. And the money will probably come through the same system we see on the ground. Now, once you're living in space, I don't know what sort of monetary system they'll have between people that live there and the companies that perform there. But I can imagine at some point it might be completely different from what we see here. I know there's a big move to Bitcoin and digital cryptocurrencies today. I couldn't even tell you what sort of money they'll use, but I do know that there's an awful lot to be made. And platinum and precious metals alone will do that for us. But I think the real benchmark will come when we start setting up air factories, water factories, and making organic materials in space from material from asteroids, that sort of stuff. And that's where the real value is, because right now to survive, we need air and water. And organics would allow us the option of making solvents and plastics and food. So the real big breaks aren't really going to be the precious metals, which certainly have their value, but the things that support life. Now, one of the things that isn't talked about a lot, but we hear about asteroid mining, is the dwarf planets offer a lot of options because they're almost the size of planets. They have very low gravitation. Many of them are around asteroids or other organic material sources, and asteroids, some of them do have organic matter on them. Let's see how well this will work. Computer.
What can I do for you?
What is a dwarf planet? What's a dwarf planet?
A small planet of about 1,000 kilometers or less.
Please list the dwarf planets.
Certainly. They are Pluto, Ceres, Makemake, Haumea, Eris, Sedna, and Orcus.
So I'm interested in, let's talk about organic compounds.
Are you interested in organic compounds?
Yes. What does organic compound make you think of?
Too many associations to list. Here are some: epoxy, dextrose, starch, aldehyde, styrene, solvent, benzene.
I'm interested in tholin. Tell me about...
Empty line.
I'm interested in tholin. Tell me about tholin.
Of course.
What is it?
That would be a mixture of simple organic compounds often formed by lightning or ultraviolet light.
Thank you. Tholin is what makes many of the dwarf planets red, and if you look at Pluto, it has a reddish color to it, and all of the dwarf planets out in that area do as well, and it's because the ultraviolet from the starlight and sunlight has polymerized or formed these compounds from the raw material that's around them. And so this is really a treasure for us, and if we set up factories that mine and use this stuff, then we can produce all the industrial materials we need, like plastics and insulators and solvents. And so industry in space is not just metals and rock. You have to have the stuff of life, and tholin basically is the stuff of life. And I guess that takes it back to I think it was Armando who asked the question about star jelly. There is the possibility that there is something out in the outer planets or even in some comets that is organic in nature of that sort. We do know that there are organic molecules out there. So the real industry starts when we can get not just metals and make fiberglass and lenses and insulators and beams, but also the things from organics. Now, one of the big things about space travel is there is a strictly limited number of destinations where we can send people right now. We can send machines anywhere, but if you're sending people, it means that you have to have certain resources in place for them to survive. Otherwise, you're going to have a monumental payload of food, water, and air, and all the other things it takes to keep people alive. This is the big issue between manned and unmanned missions. An unmanned mission can be done for a certain amount of money, but if you put a person in it, it goes up about 50 times in cost. It literally is 50 times more expensive to send a human being on a mission than just send some machinery. And so this is why we send a lot of spacecraft to the outer solar system and other planets, because number one, they really are not as prone to damage from radiation as human beings. And, well, if it breaks, you've lost some money and some hardware, but not a human life. If you send people, the craft becomes massive, and the supplies to keep them alive become massive. And then you can't just send the thing out. You have to bring it back because you've got people in it. So when we start thinking about where we're going to travel in the solar system, we need to begin setting machinery up that creates destinations where people can go and not worry about when they get there. So one of our major goals in confronting space travel today is how we can make this something that everyone can do. If you think of it in terms of an airline, if you get on a plane, you know they're not going to fly you into a volcano. They're going to put you somewhere where you're safe. You're going to land in an airport 900 times out of 1,000. And, well, I would hope better than that, to be honest. But the fact is, if we send somebody into space, we have to send everything with them. Now, if we had automated machinery making, let's say, a lunar base, and it set everything up, including gardens and air and recycling and water, then you'd have 30 people there right now. And if you sent a package to orbit Jupiter and land on one of the moons, and you had radiation shielding and homes and everything, you'd have a crew out there, like a research crew, before you know it. Space factories give us the opportunity to manufacture the shielding that can keep human beings safe on a journey such as this. And long-term shielding generally means going underground on a moon or asteroid. But if we had, let's say, a lunar sandbag factory, and this could be done extremely easily, we could literally catapult sandbags off the surface of the moon to a catcher in Earth orbit or lunar orbit and start putting real shielding around some of our space stations. This is a quantum leap forward in space travel. It's the ability to shield our people and components so that they remain safe. So there's so many things to think about when we talk about space travel. Just getting there fast is fine, but having a place to go that's worth going to is a large part of the equation. So space industry gives us not just factories to make widgets and precious metals and so forth, but it also gives us the ability to manufacture places to be. And that gets me out of von Neumann machines, which is another one of my favorite subjects, self-replicator machines. We'll talk about that in a show soon. I'm going to devote an entire episode to von Neumann devices. And, there's also a lot we could say about propulsion systems. I haven't even really touched on the specifics other than saying that there is rocketry and there's ion craft and plasma engines. But there are also light sails and tether craft and all kinds of other things that we could be talking about, as well as the new EM drive, which is a reactionless thruster, which has been tested and actually works. And that's big news because you don't have to throw mass away as long as there's sunlight to electrically power it. You could be moving the thing around for free. So there are a lot of options. And right after the break, we'll have our last few questions and statements from listeners, and we'll do our Singularity Watch and book recommendations. So we've still got a lot to talk about on the show and a lot more to do on future shows on the subject of space travel and all the niceties and details of it. So at this point, I'm going to let the computer announce the next segment. Computer.
What can I do for you?
Announce the break, please.
This is Talk Universe. We will return after the break.
And there you go. So in the final segment of the show, we have some interesting things to talk about before we wrap everything up. I think that we've had some pretty good questions tonight, and I know that there are a lot more things to talk about in space travel in general, but we set a theme and it seemed to play out pretty well. Let's look at some more of our questions from people. Hang on just a second here while we find out how many we have left. Computer.
What can I do for you?
Do we have any questions remaining?
I have 2 questions remaining in the queue.
Okay. Computer, what is the next question?
Marlon asks, can we use magnetic fields to move a spaceship?
Actually, yes, we can. There are a couple of ways to do it. A lot of people would think of it as somehow projecting a magnetic field like a big magnet out of the back of your ship and flying that way. Now, if we use a long wire or a pair of wires called a tether and run a current through it in the magnetic field of the Earth, it actually can repel the ship gently from the Earth's magnetic field, and you can move to a higher orbit using nothing but electricity that way. But there's a point where the magnetic field of the Earth becomes too weak to do this very easily, and the mass of the tether and the amount of power it takes are both issues that you have to keep on top of. You can use a big wire tether, like a loop magnet, to repel yourself or pull yourself toward the Earth, but it has a limited range as to how effective it is. On the other hand, we can make linear magnetic motors, something like a cannon, and basically what they are, in the simplest form, is a series of magnetic coils, and the first coil drags the payload forward magnetically and then turns off, and the next one turns on and drags it some more. And they're spaced close together at the start and farther apart toward the end of the linear motor. And this induction motor can actually be used to throw payloads without using any fuel, like a catapult. So think of it as a magnetic catapult. It was something that was researched by Gerard K. O'Neill, who was one of the people who founded the L5 Society many years ago, a space colonization group. And he worked out of Princeton and actually built them with just a few dollars worth of scrap parts and some students. So yes, you can. And magnetic motors or magnetic catapults placed on airless bodies like the moon can be used to throw payloads and hardware into space for a catcher to snag in flight and then put it to use somewhere else. So it's a fuel-free, electrically driven, very clean and simple method of throwing things around. Okay, let's see what our last question looks like. Computer, what is the last question?
Singer14 texts us a question. I have seen GoPro cameras sent to the edge of space on rockets and balloons, but I haven't seen one in orbit yet. Why is this?
That's because it's pretty easy in terms of the technology for a hobbyist or a couple of hobbyists to get together and send a balloon or a small rocket up to a considerable altitude. It doesn't take an immense fortune to do that. But to reach orbit is a different animal entirely. You see, it's easy enough to reach altitude, but orbit implies not just altitude, but also a lot of speed. At the start of the show, I was saying that a satellite has to move at least 5 miles per second in order to be in orbit. It has to do that above the atmosphere. So you would have to go above an altitude of 200,000 feet and have a significant forward velocity in order to hope to achieve even one orbit around the Earth. And normally you would go much higher than that. So this is why the amount of energy it takes to put something in orbit is significant, and it takes a lot of hardware to do. So it's possible to build a small rocket that will take a GoPro to orbit. It certainly is possible. We've seen rockets slung under jets, fighter jets that are taken to high altitude where they release it and the rocket fires and actually goes into space. So that's not out of the question. It certainly can be done. But for even small companies, it is difficult. So you're not going to see it until we have either better propulsion systems or something along those lines, something capable of getting something up to very high speed cheaply. And the answer could very well be smaller jet-powered air-breathing carrier vehicles, because this eliminates a huge burden of fuel. The oxidizer typically is 80% of your fuel mass. So if you could get rid of that by making it an air breather, you could cut down the size greatly. and then the carrier vehicle would deliver your rocket for orbital insertion to high altitude at fairly high speed. And the little rocket would do the rest of the job. And the advantage of that is your carrier vehicle can then turn around and using GPS fly back to the launch site. So I do expect we're going to see some things like this developed pretty soon, because it's really an obvious solution. Okay, now I'm going to do our book recommendation. And computer, what is our book recommendation?
That would be the book that we promote or recommend.
Yeah, that wasn't exactly what I meant. I want you to give our book recommendation. Computer, say our book recommendation.
Our book recommendation.
Okay, that wasn't what I expected. I'll do it myself. But anyway, the book recommendation this time is The High Frontier, which is an older book, one I read pretty much when I was a kid. It was published in the early 70s, and it was all about making life in space work. And it was how to build space colonies, what your expectations would need. It's out of print now, but there are many older copies that you can get very reasonably on Amazon. Here's the technical spec for the book. Now, I mentioned the name Gerard K. O'Neill a little earlier, working at Princeton University as the fellow who helped develop the mass driver, the electromagnetic linear motor. And he is the author of the book The High Frontier, Human Colonies in Space. It was published by Apogee Books, and it made it to its third edition. And Freeman Dyson wrote the introduction for it. It's a heck of a good book. It's rather expensive right now because it is out of print, but you can probably find a copy at a local library and check it out. It certainly is an excellent read, all about what you'd have to live in space. If you buy it as a paperback, it's over $25. You might be able to find it cheaper somewhere. You can download it on Kindle for $6.99. But it's a fascinating read. It gives you a lot of information about living in space. So once again, Gerard K. O'Neill, who is an extremely intelligent man, was an extremely intelligent man, and he probably did a lot more than many entire organizations to promote how we will be developing space in the future. Okay, computer, please announce tonight's Singularity Watch.
This is tonight's Singularity Watch on Talk Universe.
Now, in a recent talk given by Ray Kurzweil, the noted futurist, he gave 3 reasons for us to believe that singularity is near, and the number 1 reason was we're going beyond Moore's Law. Now, Moore's Law is basically the principle that every 18 months we double our memory density or computing speed or power. And we have been doing this constantly for many, many years. And we now have reached the point where the physics may be the one thing holding us back, and yet we've found some ways around it. We're reaching the theoretical limit, and the process is now starting to slow down. You can only make transistors as tiny as you can before quantum effects cause them to not work properly. They have to be bigger than a single atom most of the time, and you're not going to get around the effects of physics. So we'll find other ways to do it, and it looks like we are really, we're speeding up overall performance by actually doing 3D stacking and borrowing tricks from neurons and so on. So we're going beyond Moore's Law. We're reaching a point where the physics of transistors is limiting what we can do with microchips, but we're finding ways around it. Reason number 2, robots are doing human jobs, and this is very clear. We've got vacuum cleaners and house assemblers and all sorts of things going on right now. There are military robots in use, and automation also applies to things like driving your vehicles. And a lot of times, we've often made the assumption that robots and programs can't be creative, and yet we actually had a book written by a machine in Japan that was recently accepted as a submission for the Hoshi Shinichi Literary Award. So creativity is starting to emerge in some of these things, and we're already looking at embedding chips in soldiers' brains, and Elon Musk says he's thinking about commercializing similar technology. So these are some amazing things that are happening. The third reason is we're editing genes. We now have tools that allow us to change some of the fundamental principles of life and how organisms work. So Ray Kurzweil is very convinced, and he makes a very convincing argument himself, that we are nearing the singularity, because at this point, the innovations will happen so rapidly, we have no way of predicting what happens next, and we don't know what the limits will be. Just to give you 3 examples, we have synthetic nanoparticles. They're tiny particles, just about 10 to 50 atoms across. And they're being made with the complexities of protein molecules now. So it's possible to make, artificial particles that have the accuracy and complexity of their natural counterparts, which would be proteins. And so the sorts of mechanisms we're making now will soon lead to, it's predicted, nanomachinery that will go in your bloodstream and will make repairs to things that are wrong with your body, biological repairs and organic repairs. And this would lead to the regrowth of limbs or the replacement of tissues that are breaking down or aging, and also with the ability to augment what's happening. So many authors of this particular article I've read made a great deal of research and advancement, and they were chemists from Carnegie Mellon University that started the initial project and demonstrated that the particles can achieve the same level of structural complexity as the natural counterparts they have, the proteins. So this is pretty encouraging. We're reaching the point of nanorobotics. Also, another very, very interesting one here. There's a scientist team who managed to hook up the brain of a paralyzed woman to a tablet computer. And so now she has the ability to go online and look things up on Google by using her brain and the tablet. So she's got a myotrophic lateral sclerosis, which is also known as Lou Gehrig's disease, and it causes progressive motor neuron damage, which means she's mostly paralyzed from the neck down at this point. But she still is very intelligent, and while unable to move and unable to communicate with the outside world, her brain still works. So basically, they've done a little work on locked-in people, and they found a way to get directly into the neural circuitry, neural prosthesis, and to train her with basically a microarray chip the size of a tiny aspirin, planted directly into the brain. And so in a very short period of time, she was able to learn how to control it. The chip learned the algorithms to decode what she was trying to do, and it gives the ability for her brain to control the mouse and the tablet and run it just as well as any of us. So this means that people who are typically locked in, paralyzed, and unable to communicate can now have a small surgery and be plugged into a tablet with wireless, Bluetooth, or whatever, and get online. Now that is astounding. So we now have the ability to put anyone mentally online. We also see microbiologists making big leaps in developing green electronics, and that's kind of a play on words. I'm sorry, let me back that up a little. The University of Massachusetts Amherst reported that they've discovered a new type of microbial nanowire produced by bacteria that can accelerate the development of sustainable green conducting materials for the electronics industry. Basically, what this comes down to is they found ways of programming biological entities to produce nanowires that are better conductors. And this means that we can make replacements for expensive or rare materials that we normally would have to mine somewhere or pay top dollar for. So the advancements keep coming faster and faster. We're now plugging people's brains directly into the internet. We're now making living particles of nanowires that can wire things together for us, and we're now surpassing the speed of Moore's Law development, and the world is changing more rapidly than ever. I mean, think about it. I am using an AI assistant on my show, and while the program doesn't always work great, I'm refining it. Say I have a fun idea. Why don't some of the listeners come up with a name for my robotic assistant here, my little AI, and we'll see who has the best name, and we'll probably name the assistant. So that's a little challenge for you guys over the coming few days. Well, this has been a wonderful show. Make you the world a better or more beautiful place for having lived in it, and I'll allow my assistant to wrap the show up. Computer, wrap the show up, please.
This has been Talk Universe. Thank you for listening. Please join us again next week.
Thank you for listening. I'm Sir Charles Schultz. This has been Talk Universe. Have a great week.